This is a LED being controlled from a web page hosted directly on a Node MCU ESP8266. There's no app, no cloud. In this video, I'll show you the wiring, how to upload the code, how to connect it, and I'll explain the code so beginners can actually understand it. So first off is, I already have it all uploaded. I'm just gonna prove it. It's a proof of concept that can work. And a lot of people, when they think of IoT and other things like that, they think it's interesting. It's hard. It's not hard. Anybody can learn it. It's simple. So I'll just go ahead and demonstrate here. I have the web page pulled up off of a hotspot for my phone. That way I don't expose my own network. So this is on, off. I even have a toggle. So, and I'll go through that, and I'll make it as easy as I can for beginners, and I really hope it's enjoyable and easy for you all. So it's a simple design. The physical part of it all, so all you need is a Node MCU 1.0 ESP8266. Basically, what that means for anybody who's watching or deciding they might want to get into this is you just need an ESP8266 with a Wi-Fi chip. That's basically what that's saying. And you'll be programming this through Arduino IDE. I think you can use some other ones. I've always used IDE, but I'm not sure about if there's other ones out there. But really, all you need is a resistor, an LED, and something to connect back to ground. In my spec sheet, when I drew this out, I said 330 ohm resistor. I just went with a 220 ohm resistor. Basically, you can think of it like a hose, a water hose from a spigot outside. Voltage is going to be your pressure, current is going to be your flow, and resistance is going to be like a kink in the hose. Basically, certain pins on the board output a certain voltage with a certain amount of current, and if you go over that current and voltage with LEDs, they burn out quick and immediately. So we put the resistor in there just so that way it doesn't blow out. You can also use resistors to dim, or they have what's called pot resistors. You can dial them and they periodically change the resistance as you turn it. So that's another thing. I've always found great reliability in these ESP8266, but I've used lots of different versions. So it's super simple, and I'll list in the description some links to some kits for anyone who wants to. I order a lot of stuff from AliExpress. You can get it a lot cheaper than Amazon, so I'll do some Amazon listings, and I will do some AliExpress listings for some kits for those who want to get into this or are curious about which boards I actually have and what I don't have. Alright, so now we're going to put it together. Again, I'm using a 220 ohm resistor, a green LED, and some form of jumper cable. Most of these are included in kits. They'll come in packs like this and stuff like this. So you have everything in the kits, or if you already have it, but if you're more interested in the code, I'll try and put timestamps in for you. But so normally you want to do this with it offline. So we're going to go ahead and unplug it from power. And we're going to go ahead and go to D1 because that's the pin I set up in the code. If the leg will go in, there it goes. And then I'm just gonna route it here. My breadboard has some dead lanes. Just for the beginners, the lanes on a breadboard are 1. So if I did this and this, nothing would happen because that's basically one circuit there. So we're gonna go in the positive is always the long end on the LED and the short end is the negative. So we want to get the positive in that lane and then outside of the lane go here, and then we'll want to go back to ground, and that should be it for that part. And it's a very simple design. We're gonna go ahead and plug her in, and I have my laptop up with here that's gonna connect to the server. All right, and if I hit on, there it goes. It's super simple. This project is more learning and getting into the heavy coding side, and I plan to do simple stuff where you can start building stuff like this. It has no coding to it, but it's super easy to build, and it's good for practicing soldering skills. But you know, you can build stuff like this, and there are things to program these with whatever you want, but you can buy chips that are already programmed to do stuff like this. This one was pre-bought. I did not program this one, but it's just fun to do, and it does do to batteries, but the batteries were dead. So that's the wiring part. It's super simple and easy to follow along. Alright, so now that I've gone over the wiring demonstration and explaining some other things, we're going to get into the code side of it. Now, the first thing you need is IDE, Arduino. Oops. You just click the first one, and I'll have all the links in the description for you to get to it quickly. So here is the newest version, updated version. They have nightly builds. They're like kind of like beta versions. I use a nightly build. They can be buggy and have problems, but I haven't had a problem with it personally. But once you have that downloaded, I'm using a ESP8266, so you will need the libraries to define it. This is the one I use. It's in GitHub. I'll have this link too. And once you come here, you're going to scroll down, and of course, they have links that explain this stuff. But we're going to get to the important part, which is going to be, oh, I think I scrolled past it, dang it. This link right here. You're going to want to copy this link. And once you have IDE installed, you're going to want to come to File, Preferences, and under additional board URLs, you're going to paste in that package. Now you'll see something pop up over here, and it'll say indexing. And basically what that is it's grabbing a whole bunch of libraries for you. I don't have these all installed. I only have installed the ones I'm going to use. And the ones I'm using for this one is ESP8266 Wi-Fi and ESP82 web server. Now, before you can upload to your device, you're going to plug in a USB, and you have to make sure it can transfer data. Now, it's going to say COM 1, COM 2, COM 3, whatever communication port it is. The one I'm using and currently connected into it is COM 3. But I'll just click COM 1 for you. It'll select COM port. And then from here, I'm going to type 8266. And it's going to pull up stuff that's referenced. And I will go down to the one I'm using, which is Node MCU 1.0. Now, this is very important because not all of these library devices code the same.
if I selected generic ESP8266 module and tried to upload the code I have written, it will fail. So you want to make sure you're using the Node MCU 1.0 if you're going to use my code or follow along. I will use Node MCU a lot if I'm using 8266, which currently I have 8266 boards. I don't have any more ESP32s, but we're going to stay on port 3. Alright, so now we're on to the code, and I know it's going to really look like a lot, but I'll try my best to go line through line with you so you can follow along, but also this will all be in my description for you guys to just copy and paste. There's a couple things you'll have to change when you use it if you copy and paste it, but hopefully by the end of this it'll all make sense. So we'll just go ahead and start with my note section first. So basically the /* everything at the top that's with this /* comments is just notes for people like you and me. The ESP will completely ignore it when it goes to run the program. So the project that I did is very simple and great beginner friendly for those who want to get into the web server side of things. And you could take the web server out of this and instead say and do like a push button. You wouldn't have to do a server, but I like doing things on servers. It makes things quite interesting, so hopefully we can do that together. Now in the future, I won't always have everything web server based. Of course, I'll do buttons and stuff. So basically, this is a ESP8266 web server with LED control. It connects to the Wi-Fi. I use the hotspot. It prints status and IP addresses to the serial monitor, and the web page has an on-off and toggle and status display button. Now the wiring I did D1, which quickly I can pull up a ESP8266 module. So this is basically what you're gonna want to have one of these, and I can have a picture or a link to a picture for you guys to understand. So D1 is this pin right here, and it's also called GPIO 5. Now you'll notice that a lot of these other pins can be used as GPIOs, or they have other functions, and we'll get into those other functions in the future. But for now, you just want to focus on D1. And I have a 220 ohm resistor that goes into the positive side of the LED, and then the negative side of the LED is going to ground. And now in the short little video I did showing it working, you can see that I used a jumper. If you plan to solder this, you'll have like a board to solder it with. Alright, so we'll move on. And that's the end of the note section. Let's just get that behind us. So these hashtag includes, so they include ESP8266 Wi-Fi H. That is a import for the Wi-Fi library so that the ESP8266 can connect to a wireless network. The include ESP8266 webserver.h, that imports the web server library so the ESP can host a website. Now I have an edit these section. This comment should be kind of yelling at you. You need to change these two lines. Now in there right now I have my hotspot name, or you want your network name or whatever, and your Wi-Fi name will go SSID or whatever it's called. For me it was Cameron iPhone hotspot, Cameron iPhone 17, that's the name of my hotspot. And then below that is const char, and that password, that's going to be the password to your Wi-Fi or hotspot. And you got to make sure you replace it exactly how you put it in to log in, including capitals and spaces. That's important. So from there, that's the end of the edit section. LED pin server creation and state tracking. Choose your LED pin. D1 is a safe default. When we pick what pin we're using for the LED, D1 is a very common safe pin to use. A lot of pins have different voltage outputs and different current outputs, and D1 is safe with the resistor in line with the LED so that it doesn't burn out. Now, unit 8_T LED pin equals D1. That is a constant named LED pin, and it sets it to D1 so that we can reuse it anywhere within the code. Now, going down to ESP8266 web server. This makes a server object running on port 80, and that is a very normal port to use for a website. There are lots of websites out there that use this port by default. Now, I'm not sure like if Google runs on port 80, but there are websites out there that do run on port 80. So ESP8266 web server, server 80, you see that on line 24. This makes a server object running on port 80, and that's a normal website port. Basically what I just said. And track LED status, you'll see that on line 26 with a // so it's a note, so the ESP does not read that. We also use this code to remember if the LED is currently on or off. Basically, it's going to say if it's on, it's going to display on. If it's off, it's going to display off. And it's a good way to keep track of if you're not by the device and you're somewhere else, it's a good way of knowing what is going on. So next is bool LED on equals false. This is a variable that stores the LED status, and it starts false, meaning off. So the set LED helper function below that, this is the next function, and it's basically just a helper. It keeps our code cleaner. And void set LED bool on, this function is called to set LED, and it receives one true or false input. LED equals on. It updates our LED on variable so the program remembers the state. Digital write LED pin, LED on, high or low. You can see that there on 37. It actually controls the pin. If LED on is true, it writes high, otherwise it writes low. And basically what that means is a high is a 1 and a low is a 0. 1 is on, 0 is off. And that is the end, basically, of the helper function. It's just helps us keep everything clean. So now we're down into the little bit tougher part. And this is going to be the tougher part of all code, I think. Until you really start getting into long scripts. I think I had one script that was 800 lines. And that's also where I suggest you kind of put in notes like I have, so that way you don't lose your place within the code if something goes wrong. So now we're going to go over the HTML. So string equals RHTML. You can see that up, where is it? String HTML RTML right here, line 39. This starts a raw multi-line text block. It lets us use HTML without escaping a bunch of characters. Now doc type HTML. This tells the browser this is an HTML document. And then we have HTML. You'll see that on line 41. That's basically the start of HTML. So you kind of go in a process. You go, this is what this is what's going to get sent, and now we got to make what we're going to see. So we have header, basically. The head section is where we're going to put settings and styling. Now I have meta name viewport context with device width initial scale 1. This makes the page scale correctly to a phone screen. It may be a lot smaller if you do it on a laptop or a browser. Title, ESP8266 LED control, and then in those like brackets they have title. This is a tab title in the browser. Style, we add some quick CSS styles to make it look nicer. So for body, font family, Arial, sans serif, padding 16 pixels. This sets a basic font and spacing. Now, dot box max width 520 pixels, margin 0, auto. This keeps everything centered and not super wide. H1, you'll see that on line 48. I'll occasionally remind you what line we're on. Font size 22 pixels. This is the font size for the header. In status, and then you'll see 3 dots. There should be 3 dots on status. Well, no, not exactly 3 dots, but dot status. I have my notes over here. This styles the status box so it looks like a nice rounded card. So you'll notice if you guys use my code, the boxes are nice and crisp. BTN. This styles the links to look like big buttons. So inside there you have inline block padding 14 pixels by 18 pixels. Basically how big it's going to be. And the margin 8 pixel by 8 pixel. Yeah. BTN active, transform scale 0.98. This makes the button shrink slightly when you press it and make it look like a click effect. Okay, scroll down a little bit in here. Style. You say this in the code or your sketch when you want to have an end of style. Head. You say that when you want to end the head. And same with body. That is the visible part of the web page. Okay, we'll let this sink in for a second. I'll go ahead and scroll down now. Div class equals box. This is the centered container for your server. Node MCU ESP8266 LED control H1. This is the big title that I have up at the top. Alright. Div class equals status LED is B HTML. This is the status line. We stop the raw HTML right there because we're about to inject the on or off text dynamically. That's for like the status. Okay. HTML plus equals state text. This line adds the on or off text into the page based on the LED state, which I talked about a second ago. HTML plus equals R HTML B div, and they're all in like the I don't even know, the brackets, I guess we'll call them. We reopen the raw HTML and close the bold tag and status box. Class equals btn href on A. This is a button link that visits /on when you press it. So that would send it sends the information back to the ESP, and the ESP knows to send a 1 to turn it on. Alright, moving on. A class equals button href off. This one visits /off, the same as /on. Class button href toggle. This one visits toggle, and depending on whether it's on or off, it's gonna send a different signal, and that's based on the state. Alright, and now we have P styles, and I kind of have that filled in for you. This is just a tip message for troubleshooting. If the page doesn't load, this is what you should check. And then we have a bunch of /p/div/body/html. Basically, that's telling you close the container, end the visible web page, end of HTML page, and with the HTML at the end that isn't a slash, that ends the raw HTML block. And after that, you've finished and set up a web page. And again, I will have this in the description so you can kind of dissect it yourself and mess with it and try and change things, change the pixels. And of course, if you guys have any problems, you can comment in the comment section and I will get back to you. Alright, so that is that. And then the return HTML just means it's looping infinitely. So now we're on routes. We create functions that run the browser like they visit different URLs. So we'll start from the top again. Void handle root. This runs when someone loads the main page. Server.send200 text HTML make page. This sends the HTTP 200, which means success, and it sends the web page HTML to host the website for you to see and connect to. And then end root handler. That's what the bracket underneath is for. It just ends that line. So void handle on. This runs the user's clicks when the user clicks on the on button. And then it set LED true. The LED will turn on. It gets sent to 1. Server send header location. This tells the browser to go back to the home page after we click, whether it's on, off, or toggle. Alright. Server.send 303. 303 is a redirect response, so it automatically reloads the web page. And then, as you'll see, we'll have another bracket, and that's end of handle. Void handle off. It's the same idea, but for off. It sends a low, so it turns the LED off. Server send header location / redirect back to the home page. Server send 303 send the redirect. And then we have another bracket to end the off handle. Void handle toggle. This runs when the user clicks toggle. Set LED on. This flips the state. If it was on, it goes off. If it was off, it goes on. Like I said earlier. It depends on the state of the LED. Server send header location, redirect to home, server send 303, send redirect code, and bracket end of toggle handle. You'll find when you code these things, there's going to be lots of loops, and it's okay to do it that way. There are ways to really compact your code, but I like to code like this. That way I have space and I can make out what's what. So we have here void handle not found. I'll scroll down for you. This runs if someone visits a URL we didn't define. Server.send 404 text plain 404 not found. 404 means not found, and we just send a plain text message back. And then we have a bracket to end that handle. So now we are into a optional spot of it all. This is a debug section I included into it, and I'll go over this too. You don't need it in the code, but I have it in the code. So void connection Wi-Fi, this function handles connecting and printing info. Wi-Fi persistent false, this tells us the ESP does not constantly save Wi-Fi data to flash memory. It helps preventing it from wearing out. Wi-Fi.mode, Wi-Fi SDA. SDA mode means the ESP acts like a phone connecting to Wi-Fi, not creating its own network. Wi-Fi.set auto reconnect true. If the Wi-Fi drops or you lose poor connection and it disconnects, it'll try and reconnect automatically as soon as it sees it again. Wi-Fi host name ESP8266-LED. This sets the device name you might see on your router list. So if you were to run an IP check, or I use, I think it's called Angry IP, it'll show you all the devices on your network. It'll just show up as that name. And after that, we can start printing the debug messages. So you'll do serial.print and print a blank line just to make the serial output cleaner. Serial.printin Wi-Fi connect start. It prints a header so you know where the Wi-Fi connection starts. Serial.print SSID. This prints your network name for you. Serial print in SSID. It prints the actual SSID we set up earlier. Next is optional but super helpful. It's scanning networks. Serial.printin is scanning Wi-Fi. It's going to tell the user we're scanning. Initial N Wi-Fi scan networks. It's going to scan for nearby networks and store how many we found. It won't try connecting to them. It'll just show you what's there, what it found. If N 0. If we found none, the scan failed. Serial print in no networks found or scan failed. That will print that message. Else, otherwise, if we found other networks, it'll list the other networks if it found other networks and not the one you're looking for or trying to connect to. Serial.print networks found. It prints a label showing that this is the networks I found. Serial print in, print how many networks were found. For me, I have probably 4 different networks in my house. So it connected to my hotspot, but it also told me what my 4 networks were. And then initial I equals 0, I, and I++. It'll loop through each network one by one. Serial.print, it just adds some spacing into it so it's not all scrunched. Serial.print I+1, it prints the network number starting at 1. Serial.print, print a little close parentheses. It's got the parentheses with the quotations in it. And you can find that right here on line 128. Serial.print Wi-Fi SSID I. This prints the name of the Wi-Fi network. Serial print RSSI. Now we print the signal strength. So I believe, if I remember correctly, the lower the number, the better. Higher the number, the worse. I'll kind of scroll down for you now. Serial.print Wi-Fi RSSI. This prints a strength number. Closer to 0 means stronger. Serial.print ENC. It prints the encryption type too. So whether it's, WPA2 or whatever. Serial.print in Wi-Fi encryption type prints what type of security it uses. Yep, it's basically pretty much the same thing as I have above, but one's labeling, one's telling you. Then we have a delay 10. It's a tiny delay that keeps things stable while printing. End of loop. Yep, and then we have the bracket to end the loop through networks, and then a bracket to end scan results. And I normally leave a little blank line saying, now, that way we know we're actually trying to connect. Serial.printin is connecting. Tells the user we're attempting to connect to the network. Wi-Fi.begin SSID password starts connecting using your network name and your password. And then we have in here a time delay. So we're going to wait for 20 seconds. And in here I have long start millis, and then right here start, and then it's going to go up to 20 seconds. And since it's in milliseconds, it's going to be 20,000. So I'll go into that a little bit more here. So unsigned long start millis, that is the current time, so we can time out instead of waiting forever. While Wi-Fi.status is WL connected and millis, start greater or less than 20,000. While we're not connected yet and we haven't been able to connect, we wait till we hit 20 seconds. Delay 500, we wait half a second. Serial print period prints a dot so you can see if it's still working. And then we have a bracket and waiting loop. So now we're on to serial.printin, and that's on line 147. This prints a new line after the dots. If Wi-Fi.status WL underscore connected, we are successfully connected, serial.printin Wi-Fi connected will show up in your serial monitor. Serial.print IP address, it'll just display your IP address. Serial.printin Wi-Fi local IP, it'll print your IP address, and that will be the IP address you can type into your phone to connect to the server. Serial.print gateway, this labels the gateway. Serial.printin Wi-Fi gateway IP prints the gateway IP. I don't know how else to say it, but serial.print RSSI labels signal strength. Serial.printin Wi-Fi RSSI, this prints the signal strength of the connected network. And then we have an else in the middle. And this is what happens if you reach the 20 seconds and you can't connect. And serial.printin X Wi-Fi failed to connect, this will display a print failure. Serial.println most common reasons. It'll list common reasons so you can go through them and fix it. And I have those common reasons in there for you. A lot of hotspots use 5G. ESP needs 2.4 gigahertz. Hotspot security is WPA3 only. That's not necessarily true, but I have run into it. Like my laptop hotspot uses that. So my phone uses WPA2. There might be a mismatch in your password or Wi-Fi SSID name, or your hotspot may block clients, but I've found great success in using a phone hotspot. Let that sit in. So now we're on serial print in Wi-Fi connect end. This marks the end of the Wi-Fi debug section. We're down at the end now, so hang in with me. And again, if there's ever questions, I can definitely answer them for you. So we are on void setup. Okay. Void setup in the parentheses there on line 170 right here. This runs once the ESP boots up or resets. Serial.begin 115,200. This starts the serial monitor at 115,000 baud, so we can see the debug messages I have set up in there. Delay 200. It's a small delay to let the board settle in and not overload it or make it freak out. I've had it in the past where if you don't have a delay in there and you have really long code and it tries to do it all at once, it freaks out and it doesn't work. Pin mode. LED pin output. Sets our LED pin as the output so we can control the voltage on it. So that would be our D1 that we're connecting to, and that just lets the ESP know we're outputting, not taking in. Set LED false. Make sure the LED starts off when you boot it on. Connect Wi-Fi in the parentheses. This runs the Wi-Fi connection function we wrote. Server.on/handle root. When someone goes to the main page, /run handle root. Server.on handle on. This is when they hold on. Oh my lord, had a sneeze. Alright, where were we? Oh yeah, server.on /on handle on. They go /on to turn the LED on. Server on /off handle off. This is when they go /off, turns the LED off. Server.on/toggle handle toggle. When they go to /toggle, flip the LED state. So if it's on, it's going to send a 0. If it's off, it's going to send a 1. And it all depends on the state. Server.on not found handle not found. Anything else that goes to the not found function. Server.begin, this actually starts the web server. And then we have serial.println web browser started on port 80, and that prints to the serial monitor that the server is running. If Wi-Fi status WL connected, it will let you know if you're connected to the Wi-Fi or whatever network you're using. Serial.print open in browser http:// print the start of the URL. Serial.println Wi-Fi local IP. This prints the IP address so you can copy it into your phone browser. And then we have bracket end of check, bracket end of setup, and then loop. Loop runs forever, over and over and over. Most times you can't even tell it's doing it. Void loop. Loop runs forever, over and over and over. Server.handle client. This is super important. It listens for the website requests. Without this, the buttons won't work. So it's important you have that in there. Static unassigned long last check equals 0. This stores the last time we checked Wi-Fi, and static means it remembers the value between loops. If millis, last check 3000, every 3 seconds we do a check. Last check, millis, update the timer of the current time. If Wi-Fi.status, WL connected, if we're not connected anymore, it will let you know in like the serial monitor. Wi-Fi reconnect. Try reconnecting, but only occasionally so we don't spam it. And then we have a bracket, end of inner Wi-Fi check, bracket, end of 3 second timer, and bracket, end of loop, which you'll see here. I hope I didn't just have that cut off for you guys. But now that we've gone through it line by line, I hope that you guys can understand this a little bit more. And if there's something that was confusing, I can help you. And I'll try my best to explain it in a better way. And as we go further into this journey and what I want to do, the videos will obviously get better. That's my goal. And my goal is also to be beginner friendly, intermediate friendly, because there's a lot of channels out there. You go to watch a video and they say, oh, you should know what this is. But that's not the case, you know. If this is something you're trying to get into and understand more, or just for home fun, like me, I did this for fun. But if you enjoyed this, I plan on doing a short, a long, a short, a long, so that way you can see what we're going into, and then we'll go over the code together. And obviously, I will have the code in the description for you guys, so that way you can just paste it in, upload it, and make sure it works, or you can try and hand type it out yourself. I find that hand typing helps memory and remembering. So, but yeah, so if you consider subscribing and liking, that helps out a lot, and you'll know when the next time I post, and we can do some really cool, fun projects together. To upload the code, you're going to want to make sure you have the COM port selected and your correct device, and you're going to want to hit upload. Now you're going to see this pop up, and this is it's gonna compile the sketch. And you're gonna see a bunch of red text. Don't worry about that. It's just telling you how many bytes you've used of your RAM and everything on the board. And then here it's gonna tell you it's connecting, its features, its MAC address, all that stuff, and it's gonna tell you the percentage it's uploaded. And it's uploaded and it resets it. And from there, your code is live. So, and of course, if you ever need help, there's bits and pieces in here that can help you, and there's a lot of forums online about common issues, common struggles, and there are a lot of people out there. I can help you if you comment, or I think I have community enabled on my channel. You can go to the community area, and I'll do my best to help you. Now that we've built a ESP8266 web server that controls real hardware, LEDs, or LED, in the next video, I'll try to add multiple LEDs in brightness control. And if this helped you and you're interested in following along and maybe building this with me, I will have links for everything, even kits to get started, from Amazon or AliExpress. I recommend AliExpress. The shipping does take longer, but it's probably a quarter of the price for stuff.